Thank you. Sorry for the thing, and then I will go out. So what we want to really trying to see is whether we want to establish a framework, AI/ML framework, so that we can use it in the affiliate management. We know a lot of people are already using it. The question is whether we want to establish something under OCP umbrella so that we can develop models and whether the team can benefit out of it, right? So we have a good panel here. We have George from Google, and Panos from Meta, and we have Rahul from Microsoft, and Rahul from OSU faculty, and Changho from Samsung. And I like them to introduce themselves. Basically, I am Sammy Nachimuthu. I'm part of Intel Senior Principal Engineer. I'm leading the CSM work group. And my day job is basically like work on the firmware-related areas, server firmware-related areas, architecture, and platform architecture. And George, go ahead.
Hi, I'm George Kola. I'm from Google. I'm a senior staff engineer there, where I'm the Uber TL of all the management effort, machine management efforts inside Google.
Yes, I'm Panos, part of Meta production engineer, and I'm part of the telemetry team that is responsible for the tooling stack that will collect and propagate telemetry and aggregate telemetry for the other systems to utilize.
Thank you.
Hi, I'm Rob Chappell. I'm from Microsoft, and I work on at-scale health and performance of the Azure fleet. And like my colleague here, I also do a lot with telemetry and service of doing that. I'll also work on RAS technologies and quality of service technologies. And at OCP, I do most of my interaction with the server component resilience workstream.
Thank you. Rahul, Khanna.
Hi, I'm Rahul. I recently joined a courtesy faculty at Oregon State University. I'm also working on areas related to systems telemetry. Alongside, I've been working on integrating robotics, artificial intelligence, and augmented reality for remote operations and things like that in data center and other use cases.
Good.
Hi guys, I'm Choi. I'm a senior director in Memory Solutions Lab in Samsung Semiconductor in San Jose. I have been working on memory and SSD advanced development initiatives that includes telemetry ML project. And also I have been leading multiple open source initiatives and standard group engagement. I made multiple standards. And also we did some open sources related to standard things.
Thank you. You can see like it's a great panel here. We want to utilize their expertise and ask any questions that you have. Maybe I would start with a few questions from my side for the panel. Basically, like all of you are working on the data centers and on the AI side. What type of use cases, what do you think that the AI and ML can make use of it and you can benefit more out of it? Maybe give some examples. Go ahead, George.
Yeah, I think there are a lot of things that we have humans involved in detecting, like failures, predicting failures, like or also performance issues, or when to throw alerts. All of them could be actually like automated with AI. Like we have done like a very good job with like cooling tweaking. It's an ML AI system that actually works very well. Basically, when the parameters increases, machine learning model with a huge number of parameters can do a better job than humans can. I think like as ML AI is like growing, we'll have to like adopt it and use more of it to basically automate a lot of the things that we do in the data center.
Yes. If I may provide the long answer there. So The point is that the sophistication of the equipment, the machines and the servers we have in the data center chain increases, and exponentially, I would say. And even like with the AI hardware that we're introducing, the complexity of the system increases a lot, too much for a simple system to deal with. And the natural sophistication of hardware management is from a pre-wired system that knows like to light up one LED per failure, and then to systems that can do collection of parameters and present them and classify them with expert systems kind of designs that we have pre-wired, we have like pre-programmed the patterns, and then the evolution is statistical analysis that some people do, and all of us do, I suppose. And further on from statistical analysis, we enter the domain of machine learning and AI. Machine learning and AI is just not a simple algorithm, a single solution. There is a family of solutions over there that you can apply. But now that we are collecting signals that are complicated and correlated, and you have partial knowledge of failures, you want to explain them, you want to provide the most efficient solution in terms of repairability and best use of your hardware, then you need to replace some of the manual work that humans would do with an equivalent system which cannot be anything less than AI/ML. So we do apply some of the models in some cases, and I expect the industry and us, of course, to be seeing way more usage of ML and then AI on just explaining and analyzing failures. Of course, part of analysis of failures is prediction, is to be able to say if some symptoms that would not constitute a failure as such are indicating a failure that otherwise would not be detected by the direct like failure of the system, the direct like the system going dark or increasing its errors. So I think this is the natural evolution that we will apply our own product, which is AI/ML, on our own systems.
These guys have covered the use for detecting and analyzing failures pretty well. So rather than piling on, I'll say there's another usage that is interesting, and that's predicting traffic and behavior and using that for operational efficiency. And that's a different type of usage with different types of models. And obviously, you're not looking for these very low probability things like failures. You're trying to understand behavior and then take advantage of that in order to keep your hardware usage very high and get a lot of efficiency out of the hardware that you're providing.
I think it's a lot of details here, wealth of knowledge. I'll just say, I don't know how many of us heard of killer microsecond. Most of our telemetry is based on, millisecond kind of analysis. And what we are seeing is that with the blazing fast traffics, it becomes critical to identify the problems in a nanoseconds. So how do you find out a statistical analysis that can actually do at that time, unless you have an integrated hardware analysis that can actually tell you what, for example, your correlation change points or mean shift analysis and things like that. That doesn't exist today. Well, it exists in some cases. So that what we have to do is make that killer microsecond that's sort of latent today and bring it forward so we can use that to actually improve the tail latencies and things like that that actually occur at that scale.
Thank you.
Actually, my company provide memory and SSD components to the data centers. So I could give one example of SSD. When we work with hyperscaler guy, we got a lot of feedbacks over some failure of the device, but it takes a lot of time when we do manual analysis. But if we leverage it with ML and AI, I think we could do some almost near real-time analysis. And also, we consider that we could do fault prediction in addition to analysis itself. So ML and AI could be a good vehicle to do fault prediction. That will reduce a lot of downtime of a system in the hyperscale environment.
Thank you, Changho. Another, maybe I will ask a couple of more questions. This is probably like, since you are already using AI models, my other question is, if I introduce a new platform or new technology, like from DDR4 to DDR5 or PCIe from 4 to 5 or 5 to 6, or even a CXL, do you need to develop a new model? Or even if I say, like, I have a first generation of processor platform and second generation I'm introducing, do you need to develop a new model, or you can use an existing model to onboard the system? Again, anyone can answer, or multiple people can answer it.
Actually, when we talk about AI and ML, I mean, it's when you talk about model, it's not one model, right? It's
Right.
There can be a spatial model, temporal model, spatio-temporal models, and like kind of things what happen, right? It's sometimes what we say, what happened in the past is going to drive what's going to happen in the future. So you're trying to convert the problem into a Markov decision process, a partially Markov decision process. If you're trying to do something like a congestion analysis where you have multiple pipes coming in and trying to see what's going to happen if I increase my traffic, what happens to other. So these require different kind of models, and nowadays you see that there's a whole concept of generative models coming in. What that means is you train it once and fine tune it later. Whether you talk about LLMs, my friend at Microsoft have worked on, or some of the robotic models, the robot language models, where and then you say, hey, I trained you on a global internet scale data set. Can you then now do this small job for me? And that's how you fine tune. So it's a complex question, but what I can say is we start with some fundamental statistics. Fundamental statistics means, if I'm looking, for example, the traffic, or for example, simple things like, can I do a root cause analysis? In a microservices, you have thousands of things interacting and handing off data one another. And a small problem at some place can, make the whole traffic go down. The question is, how do I do a root cause analysis? I mean, people take days and months and man years or human years to do that kind of analysis. Now, can we build in statistics in there? For example, can I do a similarity analysis from a previous traffic to next traffic? Did my mean change? Once you have that, then you have what's called a fundamental or foundational telemetry data. Now, once you have that foundational telemetry data that has to be built into your hardware or whatnot, then you have to have an abstraction which you can standardize. You cannot standardize how you collect the data. For example, my aging data, how fast I'm aging, when my system is going to die, out of all the systems, which one is healthy and which is not healthy. Those things have to be collected and at a fundamental statistic level, which normally fall into the AI. And when we talk about learning, well, learning would be what action should I take if I see these states, right? So that would fall into something like what we use, Markov decision process or transformers or things like that. So we have to divide the problem, right? What are we solving? Are we solving a failure problem which you detect from some spatial analysis, or you're doing a time-based analysis where you say, if I see this state, I have to take this action, and then I'm going to get to this state, and when I get to this state, right? So I think when we talk about that, I don't think as of today they are transferable. But again, we are at infancy when the whole community works and start working what are the fundamental elements of this and how do we abstract it to create a standardization. I think I would put that would be a good starting point.
Thank you, Rahul.
I would also jump in. So I think you mentioned something like certain foundational models that we can actually reuse across, and there is also a lot of specializations that we do, like especially across like PCIe 4 to 5 or like DDR generation. It's also not just the data generation, it's also across manufacturers as well. We train on it, we figure out like interesting things to do with it to even predict, but it's specified to both the manufacturer and the like technology used as well. So we have to specialize at that level to find it very meaningful. But there are also some foundational things that we can do that's actually common across like all DRAM, right? Like that we try to leverage across. But it's actually like that's actually a problem with ML AI as well. You need to collect data so that your accuracy increases, but that always lags behind.
So basically, like you can have a base model and you add the delta on top.
That's correct. But the base model is not as good as the specialized model.
Okay.
I just wanted to add the point that like a different platform or a different vendor isn't even enough depth. You also have to consider like the different lots of material and the combinations of those that can create problems. So it's much deeper than like I went Gen 4 to 5. You have to consider all of the factors. And like to give you an example of how it can be different, if you're getting even the exact same parts from the same manufacturer, if they instituted a new type of manufacturing screen in the middle of it,
right,
your material is going to behave differently before and after it. And if you're not accounting for that, your model is not going to be as good.
Okay, good thing.
Yeah, AI model is trained and finalized based on input data. Also, there is some common layers. If you think AI model, there is an input layer, and there is a middle layer, and there's output layer. Some output layer and middle layer could be used commonly, but at least the input part, each component has different features and different components of telemetry data. For example, in that case, my idea is that we could leverage existing one, at least some common part, but definitely we need to update or fine-tuning or modify some component-specific part. So in that context, our final model could be unique for components. But I'm pretty sure we could find some common telemetry matrices for some specific component, and we could leverage it, and we could make a common AI models for components level.
Thank you.
So my take is that it depends on how we train the model and what would we consider the input. Because if we were to train them on a flat list of manufacturer part numbers, for example, as soon as we introduce a new manufacturer part number which has a different topology or something, this model will fail. But if we can have the sophistication to also train the AI model, the system, to recognize the topology, to read that topology of some hardware map, of some very structured annotation that we already have. We do have the designs for everything we build. Then the model should be more aware and detect the commonalities or the differences from the old part, let's say the old server SKU, to a new type of server or a new topology that has some different layouts and some different messages or failure modes that it will have. So this is, the next layer of sophistication, the next generation that we would be aiming for. And in that sense, standardizing of how we will represent this structure, this topology, that's a very challenging and interesting topic that we should drive all together as an industry through OCP.
Okay, thank you.
Another thing to throw in, which hasn't been mentioned, is the software and firmware versions that are running on platforms, which also strongly can correlate with failures.
Yeah, because you can mess up the thing programming, then you'll run into problems.
There's mitigations that come in the new version of firmware or something like that. And so if you're trying to predict failure, it matters which one you're running.
So another...
We have a question there, do we?
You have a question there?
Are we open to questions right now?
Yep.
You can...
Sammy wanted to ask his first and then open it up.
Okay. I have one more last question. Then I will open the question for you. I think as you are discussing, right, you are basically like, if you go over gen, there's delta you need to look, that means my assumption is you have to start looking at it early so that you can have the model ready when you're releasing the product. You cannot just go back and ask people to add additional hardware when the silicon is already out, right? So my follow-up question is, do we see an opportunity where we should work as either OCP or another community where we need to create a kind of a standard set of input and output, some model definitions so that people can agree and we can basically use that to kind of go and drive some changes to the ecosystem so that those things are ready when we are getting the silicon out. And also, if you have models available, maybe there is a lot of research communities can come and look at developing a model, and if you have data, then they can go and create a model and test it. That is my thought. I'm wondering what is your thought from the panel here?
Go first.
I'm a bit skeptical in the pre-constructed model because we learn so much once we get volume and traffic that it's hard to imagine that there's something that you can get ahead of time when we all have so much heterogeneity in our own fleet, let alone across multiple CSPs. Like it's hard to imagine picking up a model and having that perform well. Having said that, you can use it as a prior in your model and then kind of learn from that point rather than starting from scratch. So maybe, but I think the heterogeneity makes it tough.
So let me counter that the definition of a model can take two forms here. We could be talking about the AI model is the trained system with its parameters, but there is also a model of representing the structure, the hard facts about the components, their topology, their servers, and the layout of a data center in particular, that this is a very fixed thing. We don't need to change it or train it. It's something we have designed, we have it in our blueprints anyway. And in that terms, representing that model in a way that it can be used across the industry in a uniform way will bring the scale. And I wanted to argue here that ML and AI works better when it works at scale. So there are extensions of statistics that work better the more data you feed to them. And the challenge here is to be able to collaborate across industry to feed more data, collect more data from more sources. Let's say, what if the vendors in the ODMs could collect some initial telemetry, collect some initial models and train them before they deliver that hardware to us. And then we continue, we have like a natural bridge there that we continue training our own models, but with pre-existing data that we can have, so that the things that we will discover link and follow what was done in the manufacturing site or not, or in life cycle terms, to be able to drive these models across the life cycle of the fleet so that we can trace things and collect more data and feed our AI ML models with more data, wider range of measurements, say.
I'm not sure you countered what I said exactly. That was what I was getting at with the using a prior. But picking it up off the shelf and having it perform day one, that I'm skeptical that that's going to happen. But it's not useful.
Yeah, I would like to jump in as well. I think there are certain things we can do. I think the things that you mentioned about like a same part number, but having two different manufacturing technologies. If we standardize it, we should basically that's what we push for, right? If a manufacturing technology changes, it should be different part number or a sub part number. All of that would help, because if a part number is a factor into the model, it's a lot easier if it actually uniquely identifies the manufacturing thing, right? That part of standardization helps as well. Other is the base model, sometimes vendors will be able to give it so that we don't start from scratch, and others can actually specialize it. And also sometimes with scale comes better models if we can openly allow people who have scale to share what they've learned, right? The models that others can leverage and use, that will also be great in the future.
Yeah, thank you.
Okay. So for me, I think we need multiple steps to do it. First, to create effective AI models, so we need a huge amount of data set. So, like a data center, like a Meta, Google, or Microsoft or Amazon, if they have a huge amount of data. So if they develop some AI models and training and based on their data set, then actually when they open it and people start from there. So one good example is Llama generative AI models from Meta. They developed Llama 1, but they open source it. And people start from there and fine tuning for multiple different applications. Like this, even for this one, I don't think one standard AI model will work for all cases, all components, but we could start from one model, and then we could fine tuning, and we could leverage that one. In that way, we could build a much healthy industries for that.
Okay, thank you.
I think
Rahul.
it's
Yeah, this last thing, and we will go there. Yeah.
yeah. I think what we said is all right. I think one of the basic problems you're going to have is, the model is going to be as good as the data.
Right.
What's your data, right? What's the structure of the data? What are you reading? Are you reading,
Right.
like a continuous data? Are you reading min, max, kurtosis, skew? What are you reading? And what you are reading, and are you feeding the data like a standard basic telemetry, or you're inputting the statistics of the telemetry, and what you get out, does it make sense? So I think AI problem building the model, we all know how to do that, but how to represent the data, how to get the data right data, that's a problem. And ask anybody, data, the nature of the data and the quality of the data determines how good you're going to run. And I think that's going to be the biggest problem you're going to face.
Totally agree. And I would say that OCP work that's happening to standardize interfaces in order to read telemetry,
Right,
that's helping this problem.
Okay, good. Thank you. Thank you, the panel, and let us open up for questions. I think go ahead if you.
Great. Thank you, guys. The question I had, actually, I hope this isn't very pessimistic, is around, I completely agree with what you guys are saying. Like, if we have a standard data format, standard data schema, it makes it very easy like to collect the data that you can then use for training. Do you guys think there's an opportunity possibly lost because companies like very large data center operators, there might not be incentive to share like all of the internal data for, these are all like the SKUs we might have. These are all the, the different operating components we have. And these are all the volumes of hardware that we have. And, that is basically the corpus of the training data that each of the hyperscalers are going to be using to train their own individual models. But it seems like right now there wouldn't be incentive to pool all of that data together into one giant body. So do you think there's an opportunity lost there, or do you think this is actually something that can be resolved kind of around like siloing of the training data available?
I would think I will think of that.
Yeah.
This is something we have presented last year and the year before about the specifications, the constraints we put in telemetry sharing. And this is the white paper we have prepared. How we can structure our data in such a way that is shareable, that we can extract or isolate it from this business critical and business private data that we do not wish to share, and leave only the kind of data that can safely and accurately train a model without us disclosing what we don't want to give out. So your concern is, yes, it's like something that we have been working on and concerns us to a very large extent. And we will not be sharing that data with third parties before we resolve that.
Yeah. Okay, I agree with Panos, but one approach we could take is like a government-funded research stuff. For example, there is multiple big research institute in the U.S. Previously, when my major was networking. When I work on the networking stuff, we need a lot of traces to analyze and develop a better protocol, networking protocol. At that time, we don't have data, but like a big institute or government-funded multiple universities, they set up systems, including some data centers, and they collected the data and they share the information, make it public. That helps us a lot for the research development and research progress. I think that might be one approach because would be very challenging and difficult for data center guys to expose that kind of data.
So I can also jump in. There's also some incentive for hyperscalers to share the data. Like as Panos mentioned, they'll want to like filter out certain parts of it. But the other key thing is like innovation, right? Like what generative AI and large language models showed is that it's not just one company. There is a huge opportunity for innovation, and we can do things like a lot better if we can like share this thing, right? So it could be like it's highly possible that hyperscaler may want to filter out the data, so their model prediction maybe say like 95%, with the filtered it'll be 80%, but it'll still be valuable to pass it along, right? And that will be the value add, and that is another thing that can standardize. Like it also helps vendors as well, right? A lot of times the data that hyperscalers have, they have to share with vendors like for prediction of like SSD failures to make it better. So, but if you actually like unify it across hyperscalers, it's even more valuable.
That's what I was going to say too. It may be that the way that it happens is it becomes channeled through a vendor where all of their customers are providing them back the data, and then they're aggregating it and obscuring all of those details. So maybe that's how it can happen.
Yeah, and I would like to bring in the paradigms that have allowed the AI and ML ecosystem to thrive the last years. And one of the elements of the paradigms is standardization of formats. Like we have frameworks like PyTorch and TensorFlow that are common, or CUDA, and these have contributed to independent researchers being able to work on the same technologies and provide their expertise and do their independent research on that. Or, for example, if you take it to the very simplest form, the fact that an image file is a ubiquitous format now, and we don't need to worry about proprietary representation of images, means that anybody can take their AI models and train them on so many images. Imagine if all these image formats were patented in a way that you could only use one data set of images at a time because they're not compatible, or you cannot put them in the same pipeline. So this is what we're trying to achieve here, to bring in uniform formats so that the analysis can work through. And of course, the availability of data is something that we need to resolve or find intermediate solutions if we cannot share the entire data set in its full detail.
Okay, thank you. Looks like
Thank
there's
you.
one more question.
Hi. My question is more around telemetry, right? So some of the arguments I've seen from vendors against making the telemetry more rich is it could be a security threat in terms of side channel attacks, or it could be an IP thing which they're trying to protect. And across the different use cases, we kind of briefly touched upon, whether it's error prediction, whether it's bottleneck determination, or general usage utilization determination. Is there any guideline or mandate from OCP on a minimum set of telemetry a vendor should make available, which is also cross-examined from any security threat point of view, so that it becomes as a baseline for any device or IP coming in from these vendors to your data center, At least this is what they provide. We did talk about different interfaces or the format of the logs, but what exactly is inside, and I think Rahul also pointed out that eventually the models are as good as the telemetry and the content of the telemetry. So is there any discussion on that trend in OCP?
It's definitely a problem. And I'll add that it's not just the content of the telemetry, but it's also how it can be collected. So if you can collect something very precisely with a very short window, that's much more of a risk than something that's aggregated. So a solution could be like secure aggregation within hardware, and then we're reading out aggregated statistics, so there's less risk. But it's definitely a concern. Anytime telemetry is mentioned, the possibility of nefarious uses comes up.
And also there's a telemetry work group, right? There's a OCP telemetry work group also exists, right? If I recall, no?
Actually, I'm not sure telemetry group, but at least for SSD part, there is OCP data center SSD spec. That spec defines some telemetry matrices that can be leveraged for this purpose also. But data itself, it would be very challenging to open data set itself. But at least telemetry data matrix components or some information, there is some activities to standardize it in OCP.
Good. Thank you. Any?
There is one more aspect to what you just said, right? It's like you build a model, or let's call it a quadratic equation or anything that you can call a model. Where do you run it? I mean, you're talking about a model that runs like at a cluster level or inside the chip, right? So when you are applying the ML, it's actually getting applied at some place where you are trying to identify something. For example, I'll give an example. Let's say your hardware is capable of doing histograms, for example, and it can find out a mean shift. You say, hey, it's a mean shift. At the time I had a mean shift, what other counter really got excited? And you find out, oh, okay, this counter got excited, and maybe the problem is in this domain, for example. So if you try to solve, I mean, it depends. This is one way of looking at it, not saying that that's a. If you start looking at it, and what you're looking at is just some sort of a spike in the system, and say what other thing got spiked, right? And what do? You shortlist it and then say, hey, my problem is in my credit system, for example, in some IO somewhere, and then you can. Right? So those things, some of those things don't have to be trained as with the data. They're simple statistics that we've been learning since our childhood. They're sufficient in some cases. Not all cases, but if you're trying to make something learn, then basically you're saying, at the end of the day, I want to find something. Either you're doing a root cause analysis or you're trying to identify my performance went down. That's not typical, and there is a change in entropy. What's causing that? So it all depends upon the objective what you're doing, and not all objective may lead to. They may lead to security breaches. I mean, I'm saying, but these two things, I don't think is going to take time to converge. Even when people share data in the industry, in the medical sense, they use a federated learning where they build models to share the data and still build the models. Those things are available, but probably not in this. But in medical sciences, they do that.
Okay. Thank you. Any other questions? If not, thank you for all of you. Maybe if you want to make any closing comments, like you make any comments that you want to finally recommend for the OCP side.
Thanks for putting this together, Sam. That's my comment.
Yeah.
Thank you.
Actually, my final comment is that we may not develop like a standard ML and AI model itself, but I thought that we could work on OCP framework for utilizing ML AI models. What I meant is that there are multiple various components, heterogeneous components in data center. We could run ML AI model separately for each component. But I don't think we have a single view of a total holistic view. So if we define some OCP, like ML AI framework to provide a holistic view of multiple AI models, I think there would be a big value.
Okay, thank you. Okay, thank you, team. Thank you, panel. Thank you, all of you, joining. We'll look forward to seeing you again. Thanks.